Hi everybody, Patrick here from Engineering Shock Electronics, engineeringshock.com. This is the Epoch unboxing and getting started video. If you are just receiving your Epoch, this is the most important video of all of them. So, first we're going to unbox, we're going to do the little bit of assembly we need to do, we're going to talk about everything. So, keep track and come along with me on this magical ride. I'm going to open it up. I hate unboxing this because I just packed it up. Now you'll notice that the box looks ugly. That's because I had to reformat the box because I couldn't find an 8x8 by 3 inch box. I had to have an 8x8 by 4 inch box. And if I packed it as 4 inches, it would cost a heck of a lot more for shipping, believe it or not. Just 1 inch will make a difference. So I'll open it up. I'm going to remove everything. If you pledged towards an Epoch without the shield, you're going to receive one less NRF24L01 Plus, and you're going to receive no shield. If you pledge towards the shield, you'll get a shield and an extra NRF24L01 Plus. This is the Epoch right here. I'm going to remove it. Stereo cable. You can remove that later. That is for your little buddy talker chip. 16-digit matrix keypad. 20 female to female and 20 female to male wires. A shield if you pledge towards one. Don't need to worry about that right now. Servo motor kit. RFID module soldered. Power supply. LCD. This bag contains a USB power cable for programming and powering the board, a PIR sensor, motion sensor, 21 screws, 13 standoffs, 6 jumpers, PS2 to USB keyboard adapter, 6 RFID cards. I think that's it. Last one, there's this piece of ESD packing. Let me just open that up. Now again, it'll be smaller if you didn't order a shield. If you ordered a shield, you'll see you'll have 2 NRF24L01 Pluses, an HC06 Bluetooth reader, and an ultrasonic rangefinder. We don't need any of that stuff right now. Let me just put this aside. If you didn't pledge towards a shield, you'll just get the Bluetooth reader, 1 NRF24L01 Plus, and 1 ultrasonic rangefinder. So, our Epoch. Carefully remove the Epoch from the ESD bubble wrap. Okay, so what we need to do to get started here, we need to do 3 things. We need to put our RFID reader on. We need to put our LCD on, and the reason I did this is because I didn't want to ship with those on. I didn't want to risk damage. Plus, I figured you guys can do a little bit of work. I'm joking. I didn't actually want to give you guys any work to do, but aside from programming. But excuse me. So what I'm going to do is I'm going to take 4 screws, and I'm going to screw. Just see if I haven't already built board here. I do. From the bottom, I can do the standoffs first or last. I'm going to use 1 screw here on the top, going through the bottom. There's one in the middle, and one on each end, and I'm going to screw on these standoffs. So then you'll have 5 standoffs on the bottom. And this makes it so that you're not on top of, excuse me, you're not on top of any metal surface. That's another thing, is never ever use this on a metal surface. This is a ceramic or something tabletop. And I'm going to put 4 more standoffs on the LCD area. 4 screws in the bottom, 1, 2, 3, 4. And then I'm going to put the LCD in. And what you'll notice here, the LCD has, I think, 16 pins on it, but we're only using 6 on each end. There's 4 in the middle that aren't used. So when you're putting the LCD on, after you put the standoffs on, make sure that the pins are all in the holes. 6 on the left, 6 on the right. It should fit right in. And then carefully screw in your remaining 4 screws. Don't go overboard. The LCD is not overly fragile, but it's fragile enough. You don't want to mess with it. Now you want to do the exact same thing with the RFID reader. Start from the bottom, put the screws in the bottom, put the standoffs on. And here's a tip for actually both the LCD and the RFID reader. Don't tighten the bottom screws. You can tighten them a bit, but make it so that these standoffs are still loose in their holes. It makes it easier for you to line up your 4 screws in the top. Once all the screws in the top are in place, tighten them. You don't have to over tighten them. Don't go crazy. Just tighten the tops and bottom pins once your RFID reader excuse me, and your LCD are in place. So that is that. Now, I'll mention this now before I forget. This board has a coin battery in it. And you didn't get a coin battery, and there's 2 reasons for that. One, the dollar store didn't have enough coin batteries to supply. And 2, I can't ship with batteries, because you can't ship with batteries without a whole bunch of bureaucratic red tape. So, no big deal. You don't need the battery to start playing with the Epoch. You need the battery to save the time in your real-time clock chip. Go to the dollar store. You can get 3 for $1.25. This is $1.25 Canadian. In the U.S., you can probably get 3 of them for $1 U.S. They're very cheap. They're CR2016 batteries. Any dollar store should have them. Again, I apologize. It couldn't be helped. They're very cheap, but I mean, these can explode in transit when going air, so I did not ship them with a battery. The other thing you're going to need for the full Epoch experience is an SD card. And what I'm going to do right now is I'll show you the SD card that I've been using, and I suggest you use the same. I'm using a Samsung micro SD card, 8 gigabytes. That works just fine. Not all USB micro SD cards are compatible, but this one certainly is. Samsung is good quality, and what you're going to want to get is just a cheap micro USB to USB reader. It doesn't have to look like adapter. It doesn't have to look like this, but that's what you're going to need if you're going to want to log data to your memory card and plug it into your computer. Pardon my cough. It's not something serious. It's mainly just from exhaustion. I'm not in the greatest of health because I've just been working so hard. So, your board will come with a little buddy talker chip installed and 2 Atmega 328 PPU chips. They've got the bootloaders installed on them. They are ready to go. But we're still not there yet. We still need to do some things. First things first, you need to go to GitHub. And you need to download the CH340G driver. And so you just have to Google CH340G driver. Download the driver from GitHub and install it on your computer. And so what happens when you get that driver, actually I'll use this board, is that you'll actually you should hear your computer recognize it. Where's my US? There we go. You'll hear your computer recognize it, and if you go to control panel, excuse me, in your computer, it should say something along the lines of USB serial CH340G driver. I'm going to plug it in now. My computer recognized it. I'm going to go to my... There we go. My control panel. And I should see this. USB serial CH340G. Every single board had this check to make sure that the CH340G worked. So if you have that, if that pops up, you're golden. You can now program your boards. However, we now need to know how to program chip A and chip B. This is the CH340G chip, and what that allows for is it allows from your computer to translate USB to your Arduino. It's a bidirectional protocol changer. It's a USB to TTL bridge. It's a little chip, has its own little oscillator, easy peasy. So once you have that working, you can now program your chips, and you can also talk back and forth between your Arduino and the serial monitor and serial plotter. Now what you'll notice right here is, we've talked about this in some of the videos, it's our chip select area. There's three pin headers: transmitter, receiver, and reset. TX, RX, and RS. So we've got all the jumpers selected to the left, jumping the middle pin to the left, RX1, TX1, and RS1, which means we are programming chip A. If we want to program chip B, we have to remove these jumpers and place them on the middle and right side, selecting RX2, TX2, and RS2, which will mean we are programming chip B. This is very important. Now, power supply. Here's the neat thing. You can just use your USB to power most things on the board, and in order to do that, you just use this 3-pin header right here. It's labeled USB/EXT. EXT means external, and this is your external power supply jack. For higher power, you're always going to want to use your power supply jack. You can still communicate with the board via USB, but you're using the power supply jack to to power. So if you want to use your power supply jack, use it. Just make sure that you're selecting this jumper, the EXT on the jumper. But for most projects, you're just going to need USB. Now I'm already breaking a rule that I'm about to mention to you, but when the board is active, you shouldn't be touching it too much, just to be safe. You don't want to shock it. And we're going to get into talk about ESD later. I mean, there's not a lot on this board that's overly sensitive, and a lot of it's easily replaceable. We're going to talk about the replaceable parts in just a few minutes. But you're going to want to be careful. If you can, especially if you're using the external power supply, consider using a protected power supply. What's the word I'm looking for? It's going to drive me crazy. I'll get back to that. Just if you have a brownout, a voltage transient could destroy certain elements of this board, namely the USB to TTL bridge, maybe even the RTC, maybe the RFID reader, depending on the transient. And I mean, those are things that you can't easily replace. You can replace the CH340G and the real-time clock and the level shifter for the SD card, but they're surface mount components. They're very difficult unless you have the right equipment to do it. So you're going to want to have a what is it called? A protected power supply. I'm sorry, I'll get back to that. I'm not going to stop the video because there's just so much to talk to, and I talk about, and I don't want to stop. I don't want to forget anything. But yeah, when you're doing the projects, do them in order. Don't skip. I mean, I suppose if you're really far ahead in your ability, move ahead. But the idea of all the videos that I've created so far are to show you all the blocks and how they work. And I've still got videos to make. I still haven't done the Bluetooth video yet. And I'll do some electronic schematic discussion videos a little bit later. And I'll continue to grow the library for this board. Excuse me. Sorry. Power your power supply with a UPS, an uninterruptible power supply, if you can. It's not overly necessary, but again, you don't want to be replacing your parts. You don't want to fry your board. Most of the stuff on this board, again, is not going to get damaged by brownout, but a UPS, look into investing in one. Most computers, connect to a uninterruptible power supply through the AC wall outlet. And having one of those protects from brownouts and whatnot. Okay, so when the board's active, try not to touch it. Try not to stand on a carpet or something that's going to generate static electricity, because if you shock the board, again, not all of it is susceptible, but there are things in the board that are not easily replaced. You don't want to shock the board because then you're going to be out a fair bit of money, and this is an investment. This isn't a toy. So yeah, you want to be very careful. Don't touch it if you can help it when it's powered. Even when it's not powered, you're not going to hurt yourself. You can lick this board. Don't lick the board, but you could potentially lick the board if you wanted to. You might get a little sting on your tongue, but you're not going to hurt yourself from electricity. It's so low voltage. But again, you want to treat this board with a little bit of love. It's a big board. It's a big investment. So when it's powered, try not to touch it. You likely won't hurt it, but better safe than sorry. When it's not powered, again, you don't want to be carting it around in a place where it's not going to be shocked, If you can, keep the ESD protective bubble wrap that comes with it, if you need to cart it around with you. It's just, you want to be careful. That's all I'm saying. So you want to be careful, because I know that you spent a lot of money on this. Okay, what's next? The power supply rail near the real-time clock has 3 3.3 volt pins, 3 5 volt pins, and 6 ground pins. The 3.3 volt pins will not produce 3.3 volts unless you have the external power supply connected and selected with the jumper. It is just not available because we have a separate 3.3 volt power supply powering the 3.3 volt rail, the NRF24L01 Plus, and the RFID board, which means that without the external power supply, you cannot power your RFID reader or your NRF24L01 Plus. You need to have the external power supply for that. Also, you're going to want the external power supply for something like the Bluetooth reader. And the Bluetooth reader we'll actually talk about next. If you plug in your Bluetooth reader backwards, it's toast. Say goodbye to it. You're going to need to get a replacement. So right now it's powered. I'm going to remove power. This is the way you want to put it in, not backwards. Put it in like that, and you're off to the races. Only if you're using it, though. And that's an important part, too. You don't want to have things plugged in if you're not using them. The PIR motion sensor, don't plug it in if you're not using it. It doesn't consume much power, but the NRF24L01 Plus, don't plug it in if you're not using it. The RFID reader, you can turn off power by turning off the power pin on here. And same with the LCD. That's okay. There are certain things that you can turn off. But any of the extras, the plugins, the ultrasonic rangefinder, that specifically doesn't consume a lot of power, but it doesn't matter. Don't plug it in if you don't need it. It's just that simple. You don't want to. I mean, that's an elementary thing in electronics. It's one of the biggest things you always want to consider is safe power. Now you're plugging into the wall. You know, who cares about power? It's a few extra milliamps, not a big deal. But if you're plugging in everything on the board, you're going to create heat, and you don't want to do that. The power supply regulators aren't going to like it if they're powering 10 things at once when they're not all being used. You know what I mean? So, don't plug in things when you're not using them. And for things like the Bluetooth reader, the NRF24L01 Plus, and RFID reader, you're going to need the external audio or external power supply jack. So little buddy talker, we've talked about that before. You're going to need the stereo cable for that, and what you do is you connect the stereo output here to the stereo input of any set of powered speakers, and the little buddy talker should feed that audio signal to your powered speakers. When I say powered speakers, I mean a speaker set with its own power supply, an amplifier. It's not going to be able to power just a set of normal speakers. It doesn't have that much power. It needs its own. It just sends a very low power signal. Alright, what is next? The piezo element, right here, the vibration sensor. I'm actually going to rewrite the code for this because I learned that the piezo elements that they used, some of them are a little bit off. And by off, I mean they react to vibration a little differently than the rest of them. And it's just the nature of the beast. Sometimes these piezo elements just aren't the greatest. So I've got another piece of code that I'm going to substitute so that it works with every piezo sensor. But there's something also to be said about this. Here's a great lesson for you. Piezo discs, their worst enemy is moisture. So if you want to protect your piezo element, first things first, after I've provided the next piece of code, it should be in a week or two. You don't need to do this right away. But after I've provided a new piece of code for the earthquake detector project, and you've got it working, what you can do, it's not necessary, but what you can do is you can use a hot glue gun, obviously when the unit is powered off, and just coat it gently with some hot glue to isolate it from moisture, to effectively weatherproof it or moisture-proof it. So that is up to you. If you're in a dry place all the time, it's not going to matter. But over time, this piezo element will succumb to the will of the moisture gods. So that is your option. If you're going to do it, just be careful about it. If you make a little bit of a mess, you can clean it up. It's just hot glue. It's not epoxy. It's not the end of the world. But first, make sure that you're able to successfully complete the earthquake detector project after I've updated the program. So again, you don't need to do that right away. It is a simple project. It should be easy for you to complete and understand after about Project 10. And you're not in a rush to do this. Just consider it. The dip switches. one of the pledges, I forget who, thank you for bringing this up, but one of the pledges brought it up that you're going to want to be careful with the dip switches. They're not overly fragile, but if you're careless with them, if you're mean to them, you can break off the plastic tabs. Now, I've only broken off really one in my entire life, but I know it can happen, especially with these smaller SMD dip switches. So what I do typically is I use a nice flathead screwdriver, and I gently dig in, not dig in, but I make sure that I'm flat against the board. I just gently push it over. It's that easy. Again, I'm being overly careful here. You can be, this is my personal Epoch, so I can do what I want with it. I mean, I can be violent with it, but don't be violent with it. Be careful with it. You want to save this. You want to be as good at this board as you can, because you want to learn from it and hopefully share it with somebody when you're done with it. Thanks for listening to me talk, and good luck with your Arduino adventure.